Okay, so we are going to just start the lesson trigonometry, and before starting the lesson I will tell you that this lesson is going to be very easy for you. No doubt it has a lot of formulae, it has a lot of concepts, but if you will understand, so many things will be very easy for you. I am starting from the zero level, so if something is very easy for you we can cover it quickly. If you have any doubt, then we can discuss that also. Now, see, trigonometry, we can divide it into two words. One is three, that is try, and another is geometry. So, geometry means analysis. So, basically, what is a trigonometry? Trigonometry is the analysis of a triangle, or you can say relation with the angles and its sides. It is all about the trigonometry. So it is not necessary that it is defined only for the right angle triangle. It can be defined for any triangle. But just to begin with, we are going to start with the right angle triangle. So suppose this is a right angle triangle. Right angle triangle means where one angle is of 90 degree. In the triangle, one angle is of 90 degree. So let's talk about the sides first. The side which is opposite to the 90 degree is called hypotenuse. Is called hypotenuse, and another two sides will be called leg. Now, if I say this is a leg, this is also a leg, then there will be a confusion. So, in some countries it is called perpendicular and another is called base, or in some countries it is called opposite side and it is called adjacent side. It depends, meaning are all same. So, here I am taking this as an angle theta. Okay, so the line on which you are making the angle is called baseline, or you can say adjacent, or you can say simply leg. So what are the six trigonometric functions we are going to define? First is sine theta. Now its full name, I am sure you know this thing, its full name is like this, sine, SINE, but in short we write like this, SIN. Sine theta is equal to perpendicular over hypotenuse, means it is AB over AC. Similarly, cos theta, cosine theta will be equal to base over hypotenuse, means it will be equal to BC over AC. And tan theta will be equal to, tan means tangent. Tangent of theta will be equal to perpendicular over base, means it is AB over BC. Now these are the three basic trigonometric functions. Now from these three we can define three more, and first is cosec theta. Cosec theta is the reciprocal of sine theta, so it will be equal to AC divided by AB, means it will be hypotenuse over perpendicular. Then another function will be sec theta, secant, and it will be the reciprocal of cosine theta, and its value will be AC divided by BC, means it will be hypotenuse over base. And the last one will be cotangent theta, cot theta, and it will be equal to 1 over tan theta. This is the reciprocal of tan theta, so it will be base divided by perpendicular, means it will be from that triangle, it will be equal to BC over AB. Okay, so this is just an introduction of six trigonometric functions. Now based from all these trigonometric functions you can have some identities. Okay, what are those identities? That I will tell you, and I will tell you how to memorize so many identities quickly. Now just to begin with, first type of identity I am going to take sine square theta plus cos square theta is equal to 1. Okay, now in terms of sides if you will write, then you can prove it very easily. If you want to verify whether this identity is correct or not, you just write in terms of sides and then you will verify it. From this identity you can have two more, like 1 minus sine square theta is equal to cos square theta, and 1 minus cos square theta is equal to sine square theta. Now another identity is sec square theta minus tan square theta is equal to 1. It means it is sec square theta is equal to 1 plus tan square theta, or tan square theta is equal to sec square theta minus 1. Similarly, you can have cosec square theta minus cot square theta is equal to 1, means it can be cosec square theta is equal to 1 plus cot square theta, and cot square theta is equal to cosec square theta minus 1. These are the three identities with sine, cos, sec, tan and cosec and cot. Okay. After this, you can have complementary angle properties. Complementary angle means in geometry you have studied that two angles, if their sum is equal to 90 degree, then they are called complementary angle. Now you will see within 5 minutes how you can memorize all 54 identities quickly. Okay, and where are those 54 identities? I will tell you. First can be sine 90 degree minus theta. Another can be sine 90 degree plus theta, then sine 180 degree minus theta, then sine 180 degree plus theta, then sine 270 degree minus theta, and then sine 270 degree plus theta, sine 360 degree minus theta, sine 360 degree plus theta, and last sine minus theta. Okay, now you will see how many are these identities. These are 9 identities I have written here, and this is only for sine, and you have 6 trigonometric functions. So 9 multiplies 6 means 54 identities. You will see how can you memorize it very easily by understanding few basic things. Now before explaining you about these identities, try to understand about the quadrant system. First thing is, here angle starts from 0 degree, then after completing one quarter it comes here 90 degree in anti-clockwise direction, of course, then it is here coming 180 degree, then coming to this point 270 degree, and after completing one cycle it will be 360 degree. Now if I say that angle lies in the first quadrant, angle lies in the first quadrant, then it can be 90 minus theta, because first quadrant angle will be smaller than 90 degree, or it can be after one cycle it can be more than 360 degree also, because all the trigonometric functions are the periodic functions. So it is just a basic I am starting. In another class I will cover about periodic functions, amplitude, frequency, period, everything. Now in the second quadrant if you go, then angle will be 90 degree plus theta, because second quadrant angle will be more than 90 degree, or it will be less than 180 degree. So less than means 180 minus theta. If you go in the third quadrant, then in the third quadrant angle will be more than 180, means 180 plus theta, or it will be 270 minus theta. And if you go to the fourth quadrant, then angle can be 270 degree plus theta, or it can be 360 degree minus theta. And one more thing is there, angle can be minus theta as well. Why? Because in the angle you have studied that if you rotate the angle clockwise, then it becomes negative. So first angle will be in the fourth quadrant for the clockwise direction. So these are the 4 quadrants, and in all the 4 quadrants different sign of all the trigonometric functions are different. Like in the first quadrant all trigonometric functions are positive. In the second quadrant only sine and cosec will be positive, and other trigonometric functions will be negative. In the third quadrant tan and cot will be positive and other functions will be negative, and in the fourth quadrant only cos and sec will be positive, otherwise all trigonometric functions will be negative. Normally students memorize it like this: after school to college. like this. In the first, second and third, fourth quadrant, they remember like this: after school to college. So A means all positive functions, S means sine and therefore cosec also positive, T means tan and therefore cot will also be positive, and fourth means C means cos and therefore sec will also be positive. Now just we have to understand one more thing and then this identity finished. See, in case of 90° and 270°, function changes. In case of 90° and 270°, function changes. And what change will be there? You see, sine will be replaced with cos and cos will be replaced with sine. Then tan will be replaced by cot and cot will be replaced by tan, and then sec will be replaced by cosec and cosec will be replaced by sec. This is about 90° and 270°. But if angle is 180°, 360° or it is minus theta, then there will be no change in the function. No change in the function. If it is sine, it will remain sine. If it is cos, it will remain cos. Now you see here, we are going to discuss the first identity, sine 90 minus theta. What I told you, for 90° function changes. So sine will change to cos. So first you write here cos theta. And now we will check the sine. In which quadrant does it lie? So 90 minus theta. 90 minus theta lies in which quadrant? First quadrant, no doubt you can see here. And in first quadrant, sine is positive. Rather, all functions are positive, so it will remain positive. So sine 90 minus theta is equal to what? Cos theta. Now sine 90 plus theta. So again for the 90 function will change. So it will become cos theta. Okay. So cos theta and then 90 plus theta. In which quadrant does it lie? It lies in the second quadrant. And in second quadrant again sine is positive. You will see here the left side function, okay, not the right hand side. So again it will be positive cos theta. Now sine 180 minus theta. I am sorry for this. Sine 180 minus theta. 180 means, you see, no change in the function. So if it is sine, it will remain sine. And 180 minus theta, which quadrant? Second quadrant. And in the second quadrant, sine becomes positive. So it will be positive sine theta. Okay. Now 180 plus theta. Sine 180 plus theta means okay. So I am little suffering from cough and cold. So hello. Yeah. So yeah, no, no, it's okay. Actually, since morning I am little suffering from cough and cold, but it's okay. I can manage. Yeah. So sine 180. Now you see here what I told you for 180 function does not change. So it is sine theta. And 180 plus theta, in which quadrant does it lie? In the third quadrant. And in the third quadrant, sine is negative. So sine 180 plus theta will be equal to minus sine theta. Okay. Now sine 270 minus theta. 270 means function changes. So it will become cos theta. So it is cos theta and then 270 minus. Again it is in the third quadrant. So in third quadrant sine will be negative. So it will be minus cos theta. And then sine 270 plus theta. 270 again function changes. So it becomes cos theta. And then for fourth quadrant 270 plus. It is in the fourth quadrant, you can see here. So sine will be negative. 360 minus. So for 360 function doesn't change. So it will be sine theta, and 360 minus means fourth quadrant, you can see here. So it will be minus. Sine 360 plus theta means again it will be sine theta, and 360 plus. So it will be first quadrant. So it will be positive. It will not be negative this time. And sine minus theta. So minus theta means it lies in the fourth quadrant. And in the fourth quadrant, function becomes negative. So sine is negative. So here it comes minus sine theta. Now you see, if you understand this easy thing, this one, then like this identities you can memorize, you can understand very easily. I'm sure it was very easy and understandable for you. Still, if you have any problem, then you can tell me, you can write in the chat, I will explain you. Okay, like this you can apply, you can memorize, you can write yourself. No need to see the book even. Just take one identity, for example, say tan 180 plus theta. Okay, I'll write like this, tan 180 plus theta. Okay, and what will be identity for this? You see, tan 180, now it is 180, so there will be no change in the function, so it will become tan theta. Okay, and 180 plus, in which quadrant does it lie? It lies in the third quadrant, so it will remain positive. Okay, so this is the identity, tan 180 plus theta is equal to tan theta. Okay, like this you can solve, you can memorize the identity. Now, what next after this? After this, you can have some other identities, like I will try to write all the identities at one place so that you can understand it in better way, and you can take the screenshot also if you want. First is sine x plus minus y. Two identities I am writing together. It is sine x cos y plus minus cos x sin y. What does it mean by plus minus here? If here it is plus, then you will write plus. If it is minus, then you will write minus. Okay. Now, another identity we can be cos x plus minus y. It will be equal to cos x cos y minus plus sin x sin y. How you will memorize this? You see, in the identity of sine, in every term, one number is of sine, another is of cos. But in the identity of cos, two terms are of cos and then two terms are of sine. And if you have plus here, then here it is minus, opposite. So like this, small things if you will remember, then all identities will be very easy for you in the exam. Okay, no need to just mug up the things without understanding. Now another identities can be tan x plus minus y will be equal to tan x plus minus tan y divided by 1 minus plus tan x tan y. Okay, normally students, what mistake they do here? They just change the plus minus sign up or down. So what you can remember here, if it is plus, then in numerator will be the same sign, plus, and whatever you have in the numerator, denominator will have its opposite sign. Okay, now another thing can be for sine 2x, sine 2x. Now here you see, in the plus identity you just put y x in place of y, so it will be x plus x means 2x, so it will be equal to 2 sine x cos x, and its another identity can be 2 tan x upon 1 plus tan square x. Similarly, you can have cos 2x is equal to cos square x minus sine square x. How did I get this thing? In this identity, just write x in place of y. Okay, so you will get this identity. Now you can change into a further three identities, like 2 cos square x minus 1 is equal to 1 minus 2 sine square x, or it can be equal to 1 minus tan square x divided by 1 plus tan square x. Okay. Now another can be tan 2x is equal to 2 tan x divided by 1 minus tan square x. From where I got this identity? In this identity, just write x is equal to y. You will get this identity. Okay. Now, other than this, you can have few more, like sine 3x is equal to 3 sine x minus 4 sine cube x, or you can have cos 3x is equal to 4 cos cube x minus 3 cos x. Okay, like my purpose to write all these identities, see, I am also trying to learn with the help of some or the other hint only, and that's what I suggest to my students also, so that they can memorize it quickly. Okay. Now another can be, so other another identities are for tan 3x. Okay, sin x plus sin y, cos x plus y, cos x plus cos y. Like these are the identities, and we'll see these identities when we are going to solve some questions. Okay. Now another, I will put the chat in the chat also all the identities together in one page so that you can write it. Okay. Now you see, let's talk about some questions. And I will tell you how to solve, how to get the hint to solve the question. If angle theta is an acute angle of a right triangle, what is the length of the side adjacent to theta? Given that hypotenuse had 6 unit length and sec theta is 10 over 3. Now, first you will make the triangle. I always recommend to make the picture so that question become very easy for you. I am sorry for this picture, my drawing is not that much good. This is A, B and C. So angle theta, I am taking this as angle theta. What is the length of the side adjacent to theta? Means we have to get the value of BC. Okay, hypotenuse is 6, so this is 6, and sec theta is equal to 10 over 3. 10 over 3 means what I told you for sec, it is hypotenuse over base. Okay, so hypotenuse over base means okay. Hello, good evening. Okay, so what is the value of sec here? Hypotenuse over base. So this will be, hypotenuse is 10 and sec theta is, base is 3. Now, why they have written this thing in here in this question? Okay, maybe there is some typing mistake also, it can be, because hypotenuse they have written here 6 and then they are writing sec theta as 10 over 3. So maybe there is some typing mistake, because it cannot be 10 then if it is given here to be 6. Okay, so you can change this number. Okay, let's make it 10 only here. This is 10. Okay, so now base is 3, so here it will become 3. Like this you can see, if you remember these simple identities, then you can solve the questions easily. Okay, let's talk about this question. A cos x plus b sin x is equal to m. A sin x minus b cos x is equal to n. Then prove that a square plus b square is equal to m square plus n square. So what you can do here, you see, m square plus n square. See, in trigonometry you have so many methods to do the question. There is not like that only one method you have, what I am telling you. Okay, so you can find alternate method also, but first you understand this method. M square plus n square. Now what will be m square here? A cos x plus b sin x whole square plus n square means a sin x minus b cos x whole square. Now, sometimes in hurry, students what do the mistake here? They just write a square plus b square. I mean a square cos square x plus b square sin square x. This will be wrong, okay? Maybe you will get the answer, but this will be the wrong method because we have an identity a plus b whole square. And what is that identity? A square plus 2ab plus b square, okay? So we are going to apply that here. So it will be a square cos square x plus 2ab sin x cos x plus b square sin square x plus, now we are going to apply identity for this. It will be a square sin square x minus 2ab sin x cos x plus b square cos square x. Now you see, this is negative, this is positive, cancelled. Now we have a square, two terms written here with a different coefficient. So a square will be taken common, it will be cos square x plus sin square x. Same goes with the b square. So b square will be taken common, it will be sin square x plus cos square x. And what is the identity for sin square x plus cos square x? It is 1. So it will become a square plus b square, which is our left hand side. Okay. So like this you can prove the question. Now another question can be okay. Another question can be like, if sec x plus tan x is equal to p, then find the value of all trigonometric functions in terms of p. So what it will be? See, first we have to solve this identity and we have to get the value of p. So this is sec x plus tan x is equal to p. Now if we multiply both sides by sec x minus tan x, so what it will be? It will be sec x plus tan x times sec x minus tan x is equal to p times sec x minus tan x. It will be a plus b into a minus b. It will be sec square x minus tan square x is equal to p times sec x minus tan x. Okay, sec square x minus tan square x means 1 and p will come down and it will be equal to sec x minus tan x. And our original equation was sec x plus tan x equals to p. Add them and by adding them just you will cancel this tan and it will be 2 sec x is equal to p plus 1 upon p, means sec x will be equal to p square plus 1 upon 2p. Now just make a triangle because they are asking for all trigonometric functions. So this is, say for example, x. So this is p square means hypotenuse, p square plus 1 and 2p is this one. So it will be under root p square plus 1 whole square by using Pythagorean theorem, and this is 4p square. So this will be equal to, I am doing it here, p to the power 4 plus 2p square plus 1 minus 4p square. So it will be square root of p square minus 1 whole square, means it will be p square minus 1. So this side is p square minus 1. So we can now find all other our other trigonometric functions, like sin x is equal to what? It will be perpendicular upon hypotenuse, means p square minus 1 upon p square plus 1. Similarly, you can find other trigonometric ratios. Okay. Next question can be sec square x plus cosec square x is greater than or equal to 4. We have to prove this thing. So how can we prove this thing? See, it's very easy for us. How? Sec square x can be written as 1 upon cos square x, and cosec square x can be written as 1 upon sine square x. Now, take the LCM here. It will be sine square x plus cos square x over sine square x times cos square x. Numerator will become 1. So, it will be 1 over sine square x cos square x. Okay. Now, you see I am multiplying numerator and denominator by 4. So, it will be 4 over sine square 2x. Okay. 4 over sine square 2x. Now, you have studied that sine range of sine is what? Minus 1 to 1. So, what will be the range of sine square 2x? It will be from 0 to 1. But here sine square 2x is in denominator, so it cannot be equal to 0. Yes, so it can be 0 to 1. Now 0 to 1 means any fractional number, say for example 0 0.5, 0 0.6, anything from 0 to 1. Of course, it will be in the decimal. So 4 over any number from 0 to 1 semi open interval, it will be always greater than or equal to 4. When it will be equal to 4? When its maximum value is 1. Like this you can prove this question. Okay. You can have another methods also. Okay, this type of question can definitely be in the exam, that if cos a plus b is equal to 4 over 5 and sin a minus b is equal to 5 over 13, then where a and b lies from 0 to pi by 4, then prove that tan 2a is equal to 56 plus 56 upon 33. Now you see tan 2a, we can write it as tan a plus b plus a minus b. What I have done here, I have added and subtracted b, okay, to write in this form so that we can utilize it. So this is tan, identity of tan a plus b is tan a plus tan b over 1 minus tan a tan b. Just use the identity and you will get the answer. Now you see cos a plus b is equal to 4 upon 5, and if you make a right triangle, so this will be 4, this will be 4 and this will be 5. So by using Pythagorean theorem it will become 3. So tan a plus b will be equal to 3 upon 4 and plus tan a minus b. So again sin a minus b is 5 over 13, and you make the triangle here. So this is 5, this is 13. By Pythagorean theorem it will become 12. So this is tan 5 over 12 upon 1 minus 3 over 4 times 5 over 12. So it will be what? It will be 3 over 4, and we'll try to take the LCM as well. So it will become, just simplify, or okay, 40, 12 3s are 36 plus 20, LCM will be cancelled out, 48, and 48 minus 15. So it will be equal to 56 over 33. This is our right hand side. Okay. See, if you can remember, if you can understand this first step, how easily you can do this question. Okay. Now another question can be, prove that cos 20 into cos 40 into cos 60 into cos 80 is equal to 1 over 16. So what you can do here, you see it's matching with this identity, 2 cos x cos y. It is equal to what? Cos x minus y minus cos x plus y. So here you can see we know the value of cos 60. Yes, it is 1 over 2 cos 20 cos 40 and cos 80, and then we are going to multiply and divide by 2, and now we will make it in the identity. So it will be 1 over 4 times 2 cos x cos y. So it will be cos x plus y minus cos x minus y, and then cos 80 as it is. Now you see, we know the value of cos 60 once again. So it will be cos 60 is 1 over 2, cos 80 multiply inside. So it will be cos 80 minus cos 20 into cos 80. Now 2 will be taken LCM, so outside it will be 1 upon 8, and then cos 80 degree minus 2 cos 20 degree cos 80 degree. Okay. Now this is 1 over 8, then cos 80 minus, again it is in the form of this identity 2 cos x cos y. So this is cos x minus y minus cos x plus y. So minus of minus will become plus. Okay. Now this is 1 over 8 times cos 80 degree, and it will become 1 over 2 plus cos 100. Cos 100 means cos 180 minus 80 degree, and cos 180 minus theta, I told you what? Minus cos theta. So this will be cancelled out, and here you see by mistake from somewhere we are getting it negative, but it has to be positive, because 1 over 8 times 1 over 2 will be equal to 1 over 16. So let's take it once again. This is 2 cos x cos y is cos x plus y minus, no, plus, it will be plus. Okay. So this is plus here, plus here, plus here, and then this. Okay. Okay. So this is equal to 1 over 16. This question I have seen in many examination, including competitive examinations also, and not only with the cos, it can be with the sine also. Okay. So same identity. For what is the identity for sine? I'll write here for you. 2 sine x sine y is equal to what? It is equal to sine x plus y plus sine x minus y. This is the identity. Okay. Now another thing is, prove that, yes, if you have this type of question, then you will have to be little careful with the identities. So you see, normally in such questions we apply the identity for first and last, and then the middle two. Okay, just by regrouping. So here it is sine A plus sine 7A plus sine 3A plus sine 5A over, this is cos A plus cos 7A plus cos 3A plus cos 5A. And now we will apply the identity of sine x plus sine y. And what is that identity? I will write here for you. Sine x plus sine y is equal to 2 sine x plus y by 2 times cos x minus y by 2, and for the cos, both term will be of cos. Okay. So it will be 2 sine x plus y by 2 means 4a, I am doing it little directly, and then sine x minus y by 2 means 3a, plus same for this also identity we are going to apply, 2 sine x plus y by 2 means 4a, and sine x minus cos x minus y by 2, why I am writing sine here, this is cos a over, now cos x plus cos y identity will be 2 cos x plus y by 2 into cos x minus y by 2 plus 2 times cos x plus y by 2 times cos x minus y by 2. Now you can see from numerator we can take 2 sine 4a common, in bracket you will get cos 3a plus cos a over, from denominator we can take 2 cos 4a common, it will be cos 3a plus cos a. It is cancelled out now and 2 also cancelled out. Sin 4a upon cos 4a will be equal to tan 4a, which is our right hand side. Okay, like this you can prove this question. Yes, this question is very important for the big questions. Okay, it is very big question. You see, sine 18 degree, how you will find this value? See, we'll assume, see, what is the problem in this question? If you have some standard angle, for example, say sine 15 degree, then you can write sine 45 minus 30 and you can apply the identity sine x minus y and you can finish it. Yes, but here problem is we cannot apply that. We cannot write 18 into two standard angles. If you will write 90 minus 72, then how you will find the value of 72? Yes. So what you will do here? We'll assume let theta is equal to 18 degree. Okay. Then 5 theta will be equal to what? 90 degree. Then 2 theta will be equal to what? It will be, or 3 theta will be equal to what? 90 minus 2 theta. Now you can say taking sine both sides. You will not write that multiplying sine both sides, okay, because sine is a function, it is not a real number. So sine 3 theta is equal to sine of 90 minus 2 theta. Sine 3 theta identity will be 3 sine theta minus 4 sine cube theta is equal to sine 90 minus 2 theta means cos 2 theta. Now this is 3 sine theta minus 4 sine cube theta is equal to 1 minus 2 sine square theta. So write all the terms on one side in a proper polynomial shape. It is 4 sine cube theta minus 2 sine square theta minus 3 sine theta and plus 1 equals to 0. Now if I take x is equal to sine theta, just only to write, so it will be 4x cube minus 2x square minus 3x plus 1 is equal to 0. It's a cubic polynomial and you will see that for x is equal to 1, it will become equal to 0 for 1 or maybe for minus 1. Just let's check it. If you put x is equal to 1 here, then it will be 4 minus 2, 2, 2 plus 1, 3. Yes, for x is equal to 1, it will become 0. It means by factor theorem and remainder theorem, you can say x minus 1 will be factor of this polynomial. So make it factor. So it will become 4x cube minus 4x square plus 2x square minus 2x minus x plus 1 equals to 0. So 4x square common x minus 1 plus 2x common x minus 1 minus 1 common x minus 1 equals to 0. X minus 1 times 4x square plus 2x minus 1 is equal to 0. Now you see, product of two numbers is 0. It means at least one of them must be 0, but this first one cannot be 0. Why? Because if x is equal to 1, then what was x? Sine theta. So if sine theta is equal to 1, then theta will be equal to 90 degree, which is not here. Theta is 18 degree, not the 90 degree. So what it will be? 4x square plus 2x minus 1 will be 0. So by quadratic formula we will solve it. Minus b plus minus under root b square minus 4ac means 16, not 20, it is 16 over 2a. So x is equal to minus 2 plus minus 16 for 20. So root 20 means 2 root 5 over 8. Now you see here, numerator cannot be minus. Why? Because sine 18 degree and 18 lies in the first quadrant, and in first quadrant all functions are positive. So it will be sine 18 degree is equal to root 5 minus 1 divided by 4. Like this you will get the answer. Please practice this question once again yourself, and if you think that you are well aware now, with this question, then you can find this answer. Cos 100, cos 180, cos 18 degree. Okay. If you are good with this question, you can do this question also yourself. Like you can do sine 36, cos 36. Okay. Like this you can solve many questions yourself. Okay. Now, up to this, we have finished with the identities of the trigonometric function. And from here, if you want to ask anything, you can ask some questions. Okay. Because in the next class, I want to discuss with you about the trigonometric equations, their principal solution, their general solutions, because trigonometry is very, very big topic. And after that, I want to discuss with you some inverse trigonometric function, what will be their domain, what will be their range, what is the principal value branch. Okay. Then modulus, amplitude, frequency, period of the function, all these things I want to discuss you, but one in one class. Okay. So that lesson should not be boring for you. So today I focused only on the identities, so that you can practice some questions and you can memorize the identities. Okay. I am sure you understood something from me and this lesson was helpful for you. And please, if you think that such videos will help you to increase your knowledge, I have my YouTube channel also. That link you can find with your coordinator also in the group chat. Okay. Please like and subscribe my channel and share with your friends also. Thank you.